Hello, my amazing math students. This is Mrs. A, and I love math. Well, tonight we're working on lesson 74 in your Saxon Orange book, and it's on scientific notation, which is very fun and easy, and it is a very nice way to represent extremely large or small numbers so that we don't have to keep track of all those zeros. The zeros in a really small number can become very, very tedious. And when I was looking at this one, I had to stop and count all the zeros. And as the number gets smaller and smaller and smaller, there would be more zeros in front of the digits that are not zeros. And it just gets to be very difficult. So what we do, instead of using all of these zeros, is we basically move the decimal. So basically, I'm going to always move the decimal to the spot that is right after the first non-zero digit, okay? Because I always want this number here to be between 1 and 9. Okay, so basically this one right here is going to be between 1 and 9. I'm never going to have a digit to the left that's more than 9. So this number right here has to be less than 10. 9 point something is okay, but we can't have a 10 over here to the left of the decimal. So it's right after the first non-zero digit. So we moved it how many places? 1, 2, 3, 4, 5 decimal places. So we know that this is going to be a 5 or a negative 5. Now, it's going to be a negative 5 because this number is much bigger than this number. And I have to, if I'm looking at 4.16, I have to move the true decimal place 1, 2, 3, 4, 5 places to the left to get it back to where it really should be. Okay, so 10 to the negative 5 is really 1 divided by 10 to the 5. So you can see how that would be a very small number, as this is a very small number. Okay, so this is scientific notation. This is standard notation. And when we move that decimal, so this was the original number right there. If I move the decimal place over to right behind the first non-zero digit, and I write that number there, times 10 to the, and then 1, 2, 3, 4, 5. I know it's going to be a 5 or a negative 5. 10 to the 5 makes a number much bigger than that. 10 to the negative 5 makes the number much smaller than that because it moves the decimal from here to the left, which is where it should be. Okay, so if you had to move the decimal to the right to get that decimal where it's supposed to be for that, then this is going to be negative because it has to undo what you just did to get this number. Okay, it will always be the opposite motion because we're not trying to change the number. We're trying to represent that number without all the zeros. Okay, now here is another example. Now we have a number that's in scientific number notation. We want to express it in standard notation. It's saying start with 4.165 and move the decimal 7 places to the right. Okay, so that is multiplying by 10 to the 7th power. All right, remember if we multiply by 10, we add a 0 or move the decimal place 1 to the right. If we multiply by 100, which is 10 to the 2, we move the decimal 2 to the right. If we multiply by 10 to the 7, we move the decimal 7 places to the right. So this number, 4.165, is really in standard form 1, 2, 3, 4, 5, 6, 7. Fill in with zeros. Put your decimal there. Now, that's a really big number. So let's clarify it by putting in some commas. Okay, so since the number goes there, I'm going to move all these little humps I put in there, my little counting spots, and then I'm going to throw in some commas. 1, 2, 3, comma, 1, 2, 3, comma, 41. What's that? Thousands, millions, 41,650,000, and that's a big number. Okay, this one is another one. This one is in standard form. We want to put it in scientific notation. Let me close that one off there. Okay, so this one is in standard. We want scientific. We want to do without all those decimals. So we're going to go right there with our decimal. Right now it's here. In the real number, it's here. How many places do we move it? 1, 2, 3, 4, 5, 6, 7, 8 spaces. Okay, so 8, is it going to be 8 or -8 that we're going to use? 10 to the. Now the real number is right here with the decimal. We're moving the decimal to the left to get 7.146. So since I had to move the decimal to the left, this will be to the right. It's undoing that. So if I start there and I move the decimal 8 steps to the right, it will be the original number we started with, right? Let's do some examples. Okay, so here we have some examples, and we're supposed to write each one of these in scientific notation. So now this one is in standard notation, and we want the scientific notation to have the decimal right after the 3, the first non-digit number. So how many places do we need to move it? 1, 2, 3, 4. I moved it 4 steps to the right to get 3.16. Since I moved it to the right, then my exponent, I moved it 1, 2, 3, 4, must be -4, which will move it back to the left. You see, this was my original number, right? So now my decimal was there to start with. If I take 3.16 and I move the decimal 4 places to the left, 1, 2, 3, 4, won't I have the number that I started out with? Yes, I will. Okay, so this would be the scientific notation, and it just makes it much easier to do math with, especially multiplication and division with scientific numbers is so much easier than it is with standard form of really large and really small numbers. So here we have another one. Now it almost looks like it's in scientific notation because it has 10 to the -7, but it is not in standard form and it's not in scientific notation either. To be in scientific notation, this number right here has to be between 1 and 10, and it is not between 1 and 10. It is a very, very small number. Therefore, this number is not standard and it's not scientific. So we're going to fix that, and we're going to take this number and make it scientific notation. Now, first of all, what I'm going to do is figure out what do I have to do to get this decimal here, because I need my decimal right after the first digit. So 1, 2, 3, 4. I need to move it 4 to the right to get this to be 3.16, that number between 1 and 10, that is this digit. Okay, so I moved this 3 to the right. That means this has, 1, 2, 3, 4. 4 to the right. Therefore, this one needs to go 4 more to the left. So that's going to be times 10 to the -7, and -4 more would be -11. Now that is in scientific notation. And this one is not in either form either. Okay, it says, well, I've got this one, it's 10 to the 7, but I'm going to have to move this 1, 2, 3, 4 to get it right, 3.16. I moved that 4 to the right, which means this has to go 4 to the left to be accurate. So 10, 7 minus 4 would be 10 to the 3rd. And now that is in true scientific form. All right, so this is our last example, and then we'll be ready to do our practice problems. Okay, this is in true standard form. It is not in scientific form. So we need to move the decimal right here. So the number is going to be, so right now the decimal is always at the end of the number. You don't see a decimal at all. Therefore, it's at the end. So we're going to move it 1, 2, 3, 4 places. Now we moved it 4 places to the left. Therefore, my exponent on my 10 must move it 4 places back to the right. So 10 to the 4th times 4.78. And that is in scientific notation. All right, let's look at this one. It is not in standard form, and it is not in scientific notation either. This looks like scientific notation, but this is not between 1 and 10. Therefore, this digit would be here. It's got to go 1, 2, 3, 4 places to get in the right spot. 4.78. I had to move it 4 to the left. Therefore, I have to undo that by moving this 4 to the right. So 10 to the negative 7 plus 4 would be negative 3. And that would be the number in scientific notation. Isn't it easy? Okay, here we have a digit. Its decimal is there, always at the end. Unless you see it, it's at the end. 1, 2, 3, 4. It's got to be moved to the first, right after the first non-zero digit. Okay, so I moved it 4 to the left. Therefore, this has got to move 4 more to the right. So I get 4.78 times 10 to the 7 plus 4 more is 10 to the 11. Pretty nice. All right, these are your practice problems. So I hope that you will go and do them without my help to make sure that you know what you're doing. So copy them down and then press pause and go do them. You only have 3 practices. You don't want to let me do them for you. You need to learn how to do them yourself. Okay, so now the first one, 49,900. That's a pretty big number, right? So what we're going to do is we're going to move the decimal, which is here at the end, 1, 2, 3, 4 places to get it in the right spot. 4.99. I don't need to write down the zeros because there's nothing after the zeros that I have to keep track of. So 4.99 times, I moved it 1, 2, 3, 4 to the left. Therefore, I will undo that by a 4 to the right. And if I take this decimal and go 4 to the right, isn't that where it would be to start with? That's what it was originally. Okay, so I'm never ever trying to change the number. I'm just trying to change its form to something easier to keep track of. Okay, so here we have the same number that one was, but we have this 10 to the negative 11. This 10 to the negative 11 makes that number a really, really small number because that's moving the decimal 11 spots to the left. Okay, but let's just get this one in the right form, and then we'll adjust this one accordingly. So here's my decimal in this number. 4 steps to the left, meaning this one has to go 4 steps to the right. So 4.99 times 10, negative 11, and then 5 steps to the right, negative 11 plus 5 is a negative 6. Scientific notation. Now we have the same digits, but look, the decimal's way over here, meaning this is small, and then this is moving the decimal to the right. So this will still be a small number, but not as small, because we're going to move this one 1, 2, 3, 4 to get it right after the first digit. So 4.99. Now since I moved it 4 to the right, don't I need to move it back to the left with this? So 4 steps to the left, 3 take away 4 is negative 1. So times 10 to the negative 1. And that is in scientific notation. And we are done with lesson 74. And this is Mrs. A, and may God bless your day.